We have Tom Wiltzius and Nat Duca. They are on the Chrome graphics team and hack all day on the graphic stack. They're dedicated to making you as a developer understand what's going on so that you can make sure that your apps are fast, fluid, and awesome, and then simultaneously dedicated to improving that platform so that you don't have to work so hard to do that and you just get it for free. I'm really excited, and please put your hands together for Nat and Tom.
Hello, everyone. My name's Tom Wiltzius, as Paul said.
I'm Nat Duca. Nice to see everybody here.
Yeah, and we're from the Chrome graphics team. I'm going to use the laptop instead of the clicker so we can play videos. We're here today to talk about rendering performance. And we want to start off with a few basics that we're not going to cover in much detail because there is a ton of great content available on the web about this stuff already. We've talked about it before. Other folks on our developer relations team have talked about it before. But we want to make sure we're all on the same page.
So the pages that we want you to be on are the following, right? You got the screens here, lots of them. They're all running at about 60 hertz, but maybe not. 16 milliseconds is a number that you want to keep in your mind. We heard Ilya talking about numbers much bigger than 16 milliseconds. So this is a much smaller time frame. But it's super, super important that if you want to be smooth, you've got to hit that budget.
That's right. And there's a lot of stuff that needs to go into that 16 milliseconds. The rendering system's really complicated. We're going to walk through kind of the various stages in the rendering pipeline in this talk. But it's challenging to fit everything into 16 milliseconds. And this means that you should be working with the browser whenever possible. This means using things like request animation frame rather than a timer to run animations. This means using things like CSS animations when possible rather than doing everything yourself in JavaScript. And yeah, just like trying to play nice.
Please be nice.
There's more content available at those links.
Yeah. So, you know, we all know, and we've known for many years, that if you have good load times for your pages, your user engagement will be much better than if you have bad load times. There's another part of this business that we don't talk about, but that's obvious to mobile developers, which is your responsiveness, right? We've got two videos here going that are, you know, a good responsive page that is smooth and one that's janky, right? You've got to think of this as a first-order part of your business as creating a web app. I think most of you know this, but it's really worth hammering that home up to the bosses that this is something you don't fix at the end. You think about throughout the life cycle of whatever it is that you're building.
That's right. And especially, we're going to talk a lot today about sort of things that impact mobile devices more than they impact, say, like this laptop. And this kind of difference, this difference in responsiveness, the difference comes out much more on said mobile devices, right? This is one of the key distinctions between native application development platforms on Android or iOS and the mobile web, is that things feel webby when they lag, when they're slow, when they're jittery. And your users are going to notice the difference, even if they're not conscious of it. It doesn't feel as nice. It's one of the tells, so to speak, of a web app. And that's unfortunate, and that's what we want to avoid.
So we've been nice, and now let's talk tech.
That's right. So we're going to go through, if any of you have seen us talk before, we're going to go through sort of some content that should be fairly familiar about how the painting system works, how the compositing system works, and then we're going to talk about some stuff that we haven't talked about before. So with that in mind, we're going to go kind of fast, but bear with us. If you think about how pixels get on the screen of, say, a mobile phone, there's a whole slew of stuff that needs to happen. From the perspective of JavaScript, it's all of this stuff.
Yeah, so this sort of thing makes the actual Chrome engineers try to kill themselves because it's all a lie. But from the point of view of a web developer, there are these various pipeline stages that your content goes through. You start off with your JS and your DOM. It has to be styled. That has sort of two big steps, layout and recalc style. The first part's where you're taking all your CSS selectors and figuring out which apply to what. Second part is figuring out where things are positionally. Eventually, you've got all that stuff done. You're still not done. You've got to basically take all of that computed stuff and turn it into actual pixels, RGB values in memory somewhere or on a GPU. And we do that in two parts right now. First, we paint, which is where we take all the lines and we rasterize them. And the second part is we take all those textures that we've made and we smash them together on the screen using the compositor. And that's the stage where you hear layers come about.
That's right. And so you can actually see this pipeline in action in DevTools. We really, really like the DevTools timeline view because it not only shows you each of these pipeline stages kind of happening, but it also shows you how long each stage took, which means that you have some sense of where the time may be eaten up if you have some janky interaction on your page. And usually, the first thing I do when I'm trying to debug some slow site for whatever reason is I open it up and I take a timeline recording of whatever it was that was slow, and I start to get some sense of the breakdown of where that time is going and what it is that's causing a lot of time to be eaten.
This is your first line of defense, really, when it comes to jank busting.
That's right. And if you think about what properties you can animate in CSS, CSS will let you animate whatever you want, right? But it's important to realize that not all of these things are created equal. If you change something like the opacity value on some element, then all we need to do behind the scenes is recomposite. Turns out compositing is fairly cheap. We can do it on the GPU, and we can composite every frame, no problem. In fact, Chrome needs to composite every frame just to make a new screen image. But then you compare that to something like width or top, and all of a sudden you modify the width property and maybe some text reflows. We need to do a lot of relayout, and everything that got relayed out and maybe more stuff around it needs to be repainted, and then everything that got repainted needs to be recomposited, and all of a sudden this whole pipeline is kind of in action, which is very difficult to fit in 16 milliseconds.
You're now in danger territory.
Exactly.
The more left you go in this pipeline, the more you're risking jank.
Yeah, but it's not just the more left. There's kind of a big cliff
right about there.
Right about there. One of these things is not like the others. Painting is really slow.
It's like really slow, and we wanted to share some numbers.
Right. So this is data from Chrome Perf, which is the dashboard that was mentioned earlier this morning. We have like a rasterization time metric, and if you look at a Nexus 10 and you take a site like the New York Times, it takes 10 milliseconds to raster just the content that's currently visible, say, during the page load.
So that's better. I mean, 10 is not, like, okay, sure, fine, like, why are you on about this? But
because then you go to a site like The Verge, and all of a sudden it takes 107 milliseconds to raster.
This is not fast.
Right. And then you go to Qt Overload, and it takes 214 milliseconds to raster, right?
Which is a lovely site, right?
Right. I'm not poo-pooing any of these sites. I'm just saying, like, there's an incredible amount of unpredictability in how long things take to paint. And if you think about this in terms of frames, which is kind of a good logical unit to consider, then all of a sudden you can see that 214 milliseconds, that's 13 frames at 16 milliseconds a frame. That means that you end up in this position where if you really want to be repainting all of that content every frame, there's just no way,
Seconds per frame.
This means that your frames per second goes way, way, way down. You're nowhere near 60.
4. Is that smooth?
Right. And this is exacerbated when, as I kind of alluded on the last slide, you end up in this position where you need to paint things on a per frame basis. So we call this a paint storm. If you go into DevTools and you turn on Show Paint Rectangles, you'll get a red flash on the part of the screen that repaints every time it repaints. This is cool because it means that you can see that during this interaction, this is Nat's fat finger kind of moving up and down on a demo he made. You can see that there are key points in that interaction where all of a sudden there are these red flashes that show up and cover the screen. And this is really bad, right? Because that means that every time one of those red flashes shows up, then we're paying a lot of this significant paint cost, right? And if you were to show sort of like a timeline view of this in developer tools, you'd be able to see exactly how long each of those paints were taking.
Yeah, so, and we see a lot of sites that basically get pretty far along in their lifetime before they even look at paint recs.
Yeah.
And at that point, you've added so much complexity to your DOM. You've got 73 different things all going on. You no longer know which is the one that's causing the storm, what's going wrong. And so you want to keep your eye out for this from the beginning of your content through its lifetime in order to defend against this. Now, the defense, the first line of defense in this space is layers, right? We've alluded to it. We've talked a lot about it on jank-free. You can look at that demo and think about it in your head and go, well, yeah, there are these pieces and they're just moving around. So what we can do to make this smoother is keep each one of those in a layer and sort of add them all together. And if you sort of think about then the movement from frame to frame to frame is us just moving these layers around on the screen. No repainting is necessary, so that means we don't have to get those left parts of the pipeline running that are slow, the purples and the greens. And so in theory, this is smoother, right? And so this is just the same thing, but redone to be no repaints, or very few, and so it's a lot smoother.
Yeah, and actually you can see, it's probably pretty small on the screen, but you can see that there are some red flashes still happening along the far right side of the mobile device screen. That's just us repainting the scroll bar, which we do every
Scroll bars,
frame.
we haven't optimized them, they're small.
But you can see that other than that, there are no red flashes, right?
So
This is good. The point here is that you want to try to decompose the structure of your page into kind of logical units that map well to layers. And these logical units should be things that move together, that fade together, or that maybe stretch together. These are things that are sort of easy to express in terms of the layering triggers that we have on the web platform today.
We should make a postcard that says that, like
Yeah.
move together, stretch together.
And basically, this maps to the set of things. This maps to the set of things that GPUs are good at, right? Yeah. Like GPUs are okay at the kind of rasterization that Nat was talking about earlier, but they're really good at these bulk pixel operations.
Yeah. So think in terms of layers. It's really, really sort of that key building block right now for getting speed on mobile. But that having been said,
great, right? What sucks about this? Lots of things suck about this. We try to make layers automatically, but we can't always do it, right? Like one of the common questions we get is always, okay, so great, I see how you guys are explaining the rendering system working. Like, why can't the browser do all of this on my behalf? And believe me, we are trying, but there are some sort of fundamental limitations that we more or less can't get over. The most mundane of these, in my mind, is text anti-aliasing. You'll drop from subpixel, like LCD screen text anti-aliasing to grayscale text anti-aliasing.
Like clear type.
Yeah, if you're on a composited layer that doesn't have a solid color background. So if you're concerned about text quality, then and you've maybe manually promoted something to a layer, try to make it a solid color background, and you won't have that problem. This is the same reason that we have different criteria for automatically promoting certain content to layers on high DPI versus low DPI devices and on Android versus desktop. So you need to be testing all of these places. This sucks.
This is the reality that we live in.
There's not a lot we can do about it.
There are other things, too. So, for example, position sticky is one of the looks du jour, right? And understandably so. When you try to emulate that, a lot of the times what you end up having is you have a div that you're moving up and down, and inside it, you want a position-fixed sort of child of that div that's your sticky element. Unfortunately, when you put translate Z0 on that, that redefines at the spec level what the position fixed is relative to. If you go and do a little JS fiddle on your own, you'll find that position fixed on something that is a layer is, through translate Z0, is relative to the actual layer. So then you can't do sticky, because you want sticky to stick to the viewport. If you use this nasty little dirty trick, you might have more headway. And we're going to leave it sort of at that, because this is unblessed, but the reality of the world we live in. And this is in fact the reality, right?
This is the web, right?
And here's another little unfortunate reality. So, you know, big, tall web pages are tall, right? You've got lots of things in them. You know, 10,000, 20,000 pixels tall is not unusual. Chrome's rendering system uses layers in order to warm things up. So we are looking at all layers, assuming that they might come onto screen imminently. Has anybody ever done a trick in their app where they put something at negative 10,000 pixels and then they fly it in with an animation? Right? It looks really pretty. But the problem with that is we, Chrome, have no idea if something is negative 10,000 pixels from the viewport and can't become visible next frame, versus it's negative 10,000 pixels and the user can't get there. Mm-hmm. So this is a thing where we don't have that understanding. So if you hide stuff that the user can't get to anytime soon, that gives us less work to do. We use less CPU, and you're less janky.
Yeah, and that's all really good. So okay, this is kind of a lot of content that we just blew through. And we didn't do any kind of live demos the way we usually do, but I want to break this down to some simple takeaway messages, which is that you want to be looking for these paint storms. You can find them with DevTools and the show paint rex function. If you find these paint storms, you want to try to avoid them through implicit or explicit layer creation, if at all possible. You can see the layer borders really nicely. If you go into DevTools and turn on Show Composited Layer Borders, this is a very nice visual aid to help you with this sort of layer decomposition process. And if you're doing everything right and you're still finding that you have these paint storms and you just can't figure out why it's repainting because it doesn't seem like anything needs to, you may be right.
Chrome isn't perfect. We've spent a lot of time making this just work. There are cases where Chrome's tiny little brain or Blink's tiny little brain gets confused and it repaints the universe. If you're hitting that, try to reduce it down, pare it down, and email Tom or I or file a bug. We'll try to get that sorted out.
We've been recently on a spree of stamping out like what we call like spurious paint invalidations, and we would love to have more.
Bugs welcome.
That's right. OK, so that's rendering performance from the perspective of JavaScript, right? But if what we really want to talk about is responsiveness on a touch-based device like a mobile phone, there's another component to the entire story that we haven't really talked about yet, and that's the input, right? Particularly on a touch device, latency can be absolutely killer. And Nat's going to walk through a couple examples of that.
We got two videos going here, a good and a bad, right? This sort of should jump right out at you. If you drag something around with your finger, you want it to stick to your finger. And on the left, you've got something that's definitely not sticky, feels a little laggy if you're doing this yourself. On the right is sort of a little closer to what you want. And ideally, you get even closer as much as you can.
Right.
Now, getting to there on the web, that's the leading edge of innovation for both Chrome and really everyone. This is a hard problem.
Yeah.
But we'd like to share what we know about it today.
Right, and a little bit about what we've been doing. So if you're trying to get the page to stick to your finger, or say maybe you have like a slider widget and you really want the slider widget to stay under your finger when you slide the widget around, then you've kind of got two options. Option A is you get lucky and you happen to have an effect that can be expressed in terms of the fast scroll path. If you're on this fast scroll path and the browser is sort of doing the scrolling for you, then you just happen to get all of the best possible touch input latency because we built that part and we tried to make it as good as possible.
But the option B sort of happens when you're in a situation where you got to implement a drawer or a slider, where the actual thing, or a drawing app, the actual thing that happens in response to that input is necessarily programmatic. Mm-hmm. That is not a scroll. You need to handle that yourself. There's a different set of rules for making that fast.
That's right. So let's say you go with option A.
Because that's fun, right?
Right, and often that totally works, right? Depending on your content, like scrolling, the reason we sort of have done all this work about scrolling is that scrolling is like one of the most common operations on the web, right? And even on mobile devices. So if you're going to go this route, you want to make sure that the layers you sort of expect to have gotten created were in fact created and that they're working as intended. So this means that whatever the kind of content area that is scrolling should be in its own layer, and when it scrolls, you shouldn't see it all repainting, right? And again, it's the same couple of basic DevTools features will let you very easily visualize this along with timeline.
We're just hitting this point again, which is layers are good, but they're very hard to persuade to exist.
Yeah.
And so you have to be sort of constant vigilance here
in
order to catch that fast path.
Exactly, and a lot of that vigilance comes down to testing the right places. So it is very tempting as a developer to do everything on your laptop, right, or on your workstation. But the unfortunate reality is it's basically impossible to emulate the performance characteristics of a Android device on, say, this nice laptop. That's not just to do with CPU versus GPU speed, et cetera, but it has a lot to do with the fact that Chrome actually will behave slightly differently on Android than it does on desktop. The DPI matters, and all of this is subtle, and that's unfortunate. But the reality is, like, building high-performance rendering systems is complicated, and you need to test on the target devices.
So if you do hit the fast path, you're in a good position. We're doing a lot of work to make that feel less laggy. Chrome has been particularly kind of not good at that. Notice I didn't say bad, but we've been working.
It's gotten a lot better.
We're working hard to make that better, but that is the case for native scrolling.
Right. So what about option B?
So okay, I'm going to attempt to do a little bit of footwork here to try to say how you can make this work. This is really bleeding edge. If you want to do something with a touch listener and be smooth, you have to do these two things. You got to keep all of your costs, all of them, to less than 7 milliseconds. and you have to avoid foot guns. We'll push stack on the foot guns and talk about why I said 7.
Yeah, why not 16?
Because I felt like it,
Yeah.
really. Okay, we have Chrome running, and then we have your code, and we're sort of sharing that system. In order to get 0 latency, we have to run your stuff, then our stuff, all in that 16 millisecond budget. And oh, by the way, the operating system also is there doing stuff.
And this is the kind of thing that you don't generally worry about on say, like a laptop, because there's sort of enough performance overhead that you don't really worry about what Windows is doing in the background. But in fact, on like most modern mobile phones, even they're so resource constrained that actually some system thing coming in and running can deschedule all of the browser's threads and then crap.
So 7, keep that in mind. Keep your stuff. So this essentially means don't paint at the moment. Don't paint. Don't do heavy JS. Do as sort of minimal JS as you can.
Yeah.
You know, if you've got a layout, be very careful and avoid recalc style if at all possible. Okay, foot guns. So this is another one of those laundry slides of like there's that nice theoretical world that we talk about, and
like,
this is
here's
the
all the caveats. The first one's probably the craziest. If you want to do this, right, if you want to handle touch events yourself in JavaScript, that means you need touch event listeners, right? If you're going to have touch event listeners, be judicious about when and where you install them. Particularly, be wary of installing touch listeners during the page load, or you will risk scrolling jank and unpredictable delivery of those touch events.
So we're simplifying a very complex message with this general rule. And we'll come back to it later about the details of it. Mm-hmm. But just keep this in mind. Big listeners, touch listeners in general, have a lot of scary.
Yeah. Touch end, I'm going to let you explain.
Do I want to talk about touch end? This is also complicated. Actually, so if you drag your finger off a screen, do you get a touch end or a touch cancel?
What?
Yeah. So there's this common set of problems where people forget to listen to touch cancel, and so they get basically really weird behavior in the field, and they can't figure out what's going on. Yeah. They forgot to listen to touch cancel. It's a minor point, but very important, because people will say that you're being janky, and the reality is you just forgot to get that one event. Right. We're so trained to think mouse down, mouse move, mouse up. You know, all of us grew up like that, so this is a bit of an adaptation.
Yeah. The 300 millisecond tap delay has been mentioned in other talks and will be pounded on more. This is to disambiguate between double tap to zoom and a click. And yes, this is crappy. And yes, the browser tries to not wait if it can determine that it's impossible to zoom.
Set your viewport tag correctly if you don't care about
Yeah, just be careful. There's a lot of good content online about this one, so we won't talk about it too much. And lastly, mouse wheels. Mouse wheels obviously not so much relevant on mobile, more relevant on desktop platforms, but mouse wheel listeners have a lot of the same problems that touch listeners do. So lest you think that this is sort of limited to touch, in fact, you can shoot yourself in the foot with mouse wheel listeners too.
And there's some major websites that actually have touch listeners, and so they technically could hit all these fast paths we've been talking about latency, except they have a mouse wheel listener. They don't do anything in it, ironically.
Nope, except
but they've shot themselves in the foot, and there's nothing we can do about it.
Yeah, this is all like spec'd or de facto standard behavior, which means that this is not going to change.
It's a wild world out there.
It is.
Yeah. So remember we started off with a video of sort of a janky finger moving this thing around. So imagine your PM is like, hey, I want you to make that logo thing draggable because I'm your boss and I'm going to make you do it. So you're a good doobie and you go code it up, right? You put your document.addEventListener, touch begin, and addEventListener touch move. And you're like, look, it works. It's awesome. And then you get these reports from the field and they're like, yo, this is really janky. Like, I can't use my page. I love that thing, but like, you destroyed your page. You go to these options in DevTools and you show scroll bottlenecks. This is what you'll see on the left with a global document listener. What's happened is you've told Chrome that your JavaScript wishes to preempt any input received by the user right into JavaScript all the time. We cannot think about doing anything with your input, do any sort of fanciness that we can do until you say yes or no. Specifically, you say prevent default or fail to prevent default that event.
Right.
And so if you're going to listen to touch, you need to do it on the most specific thing you can do. And because of this whole prevent defaulting thing, remember the thing we pushed onto the stack earlier about that mysterious don't add touch before load? It's the same thing. If you have an input handler and you've told Chrome that, then any time you touch the thing that has the handler, you get automatic preempt over anything we can do, which means that if the browser is busy doing something like recalc style, we can't do anything in response to user input, and so you'll get a jank.
That means we can't scroll until your touch listener runs, or we time out and we give up.
So be very, very careful about when and where you install these listeners.
Yeah, not good. OK, we've only got 5 minutes left, and we want to talk through a little bit of kind of where we've come from in terms of the Chrome rendering stack, and more importantly, where we're going. If you've seen us give talks before, you've probably heard us kind of caveat some of the differences between desktop platforms and Android, et cetera. And there are still differences, as we mentioned before, but these days that's more about sort of like the actual power of the device and less about the rendering architecture. This is really good because it makes your lives easier as developers. It makes our lives easier building Chrome. And the sort of pace of that catch-up of other platforms has accelerated in the last year or so.
But we have a lot of really fancy technology that enables us to run smoothly on Android, and it's unevenly deployed right now. It's a lot better in Chrome 32, hugely better, but it's still not there. So this is why we continue to recommend testing on all the platforms you intend to support, at least for now, at least in terms of jank, because of these non-uniformities. It's the world we live in.
Yeah. The Android web view, though, is new and is further bringing everything in line.
We wish, though, to share some things with you, because it's not also caveat-free.
List of caveats, right?
Sorry. There is a rich tradition on the Android web view to disable hardware acceleration. There were good reasons for this in Android web view. There still are some good reasons to do this with the Chrome-based web view, but fewer and different. We're not going to explain that sort of curvature space directly, but the thing is, please, if you were in the past disabling acceleration on your web view, please revisit that decision. Check your content out in Chrome web view, see if it's better. If it is, Chrome will reward you in scores. The hardware-based rendering is really, really good compared to the software one.
Another important caveat, this is a difference. There are differences between Chrome itself on Android and the web view. One of the most significant is that the DOM size matters a lot more. Chrome tries to be smart about culling stuff that's way away from the viewport. But this gets a lot easier if the developer just says, no, this is right out invisible. This is particularly relevant to the web view because the web view has part of the web view API contract is you can ask for the whole document, which means that every time we go to record things to paint later, we have to record the entire document. We can't do any of the smartness around culling that we're trying to do. This means that we incur a lot more memory, and so you need to be careful about this. So you want to try to do your own viewporting if at all possible.
Yeah, and this is just that basic thing. Maybe someday we'll revisit that, but please keep it in mind. And just sort of a more broad thing, like jank busting in a web view Android sort of combined app means keeping the UI thread free for both components. They're sharing the same thread. You got great tooling to show which one's eating time, but you got to keep an eye on both. There's nothing that we've got that protects you against janking each other.
That's right. So where are we going next? There are these fast paths, but it's hard to get onto them, and it's easy to fall off of them. We think this sucks just as much as you guys do, and we want to make it better through a combination of improving Chrome and improving Chrome's tooling. So about tooling.
I mean, so you've seen a couple little pictures like this where we tilt the web page to the side. We think that these questions need to be easily and without a lot of thought answerable for you all to be more productive. It should be possible to see the layers. It should be possible to see why something became a layer, why something didn't become a layer. You should see your scroll bottlenecks. None of this should be so hard as it is now, and it certainly shouldn't be a soup of checkboxes.
Yeah, it's very difficult to visually inspect this. So
Mr. Paul Irish is going to be talking about this in more detail tomorrow.
That's right. Meanwhile, there's a lot that we can do behind the scenes to keep making Chrome faster, and there's a lot of people working on this. We're trying to fix a lot of the issues that make the slow stages in the pipeline so slow. So if you can't just express yourself in terms of compositing operations, there are some basic changes to layout that actually should be very cheap, right? Why can't you move something around with top if it's absolutely positioned and doesn't affect anything else? Like in theory, this should work, but like Blink is just not that smart, and so we're trying to sort of improve that, and there's a slew of things along those lines that are just under-optimized.
And so we're going to start thinking about. But in parallel with that, we're also starting to sort of get out of the monofocus that we've had for the last 2 years to try to just survive the transition to mobile. We've been just trying to scroll a web page, basically, and that was hard, surprisingly hard. We are now getting to a point where we can contemplate what should the mobile web really be from a jank perspective. How do you all want to express your intent to the browser so that we do the right thing from the beginning? We put up a list of intentionally provocative ideas here just to whet your appetite. If anybody has other ideas, if you've got strong opinions about one of these, if one of these makes you want to storm out of the room, stay and storm out of the room after you tell me why you hated it. We want to make this better. And the reason is we know that it's not good enough. And we know that now that we've got scrolling sort of figured out, we need to go and make the tools better. We need to make this more accessible. We need to make just jank on the web sort of a solved, you don't think about it problem.
Yeah, that's right. So with that, we're going to wrap up. Thank you very much for your time and attention. I'm Tom, and this is Nat, and thanks again.
Cheers.